Good day, students. How are you? The topic of our lesson is the mathematical expectation of the discrete random variable. Let we have the distributive table of discrete random variable. Discrete random variable is x, and x takes the values x1, x2, x3, etc., xk, and the probability of the probabilities, corresponding probabilities of the taking the values x1, x2, x3, etc., xk are the p1, p2, p3, etc., p sub k. It means the value x1 is taken with the probability p1. The value x sub 2 is taken with the probability p sub 2. The value x sub 3 is taken with the probability p sub 3, etc. And finally, the value x sub k is taken with the probability p sub k. And let the value x sub 1 is taken n1 times. The value x sub 2 is taken n sub 2 times. The value x sub 3 is taken n3 times, etc. And finally, the value x sub k is taken nk times. And in this case, we can give the definition of mathematical expectation. The mathematical expectation of the discrete random variable is the mean value of discrete random variable. According to this definition, mx, it is the notation of mathematical expectation of the discrete random variable. x1 multiplied by n1 plus x sub 2 multiplied by n sub 2 plus etc. plus x sub k multiplied by n sub k divided by n1 plus n2 plus etc. plus n sub k. It is a definition of mathematical expectations. That is, the mathematical expectation is the mean value of the discrete random variable itself. But the number of all cases is n. That is, n is n1 plus n sub 2 plus etc. plus n sub k. We can obtain the formula of mathematical expectation for the discrete random variable. Then rewrite the definition of mathematical expectation. mx equals x1 multiplied by n1 plus x sub 2 multiplied by n2 plus etc. plus xk multiplied by nk divided by n. Then divide the numerator by n term by term. Equals x sub 1 n1 over n plus x2 n2 over n plus etc. plus xk multiplied by nk over n. Then we can rewrite the last expression in the following form: x1 multiplied by n1 over n plus x sub 2 multiplied by n sub 2 over n plus etc. plus xk multiplied by nk over xn over n. And you know that according to the classic definition of probability, the probability is equal to the number of favorable cases divided by the number of every possible cases, and therefore it is p1 n sub 2 over n is p sub 2 and etc. n sub k over n is p sub k. Therefore we can obtain the formula for mathematical expectation of the discrete random variable. Now we can write the formula for mathematical expectation of the discrete random variable. mx equals x1 multiplied by p1 plus x2 multiplied by p2 plus etc. plus xk multiplied by pk. Or we can write this formula with help of the addition sign or sum sign. Sigma, it is capital Greek letter sigma. Sum for I from 1 to k, x sub I multiplied by p sub I. It is a formula for the mathematical expectation. Now consider examples. Consider examples about the mathematical expectation. Consider the following example. Define the mathematical expectation of the random variable x of the heat numbers under 3 shots if the heat probability under each shot is p equals 0.4. If we have no heat, then it means the discrete random variable takes the value x1 is 0. If we have only one heat, then the random variable takes the value x sub 2 is 1. If we have two hits, then we have the random variable, discrete random variable x sub 3 takes the value 2. But if we have 3 hits, then the random variable takes the value x sub 4 is 3. Then calculate the corresponding probabilities. These probabilities we can calculate by the binomial distribution formulas. P of x equals 0 out of the 3 equals C of 0 out of the 3 multiplied by P to 0 multiplied by 1 minus P to 3 minus 0 equals, it is 1 multiplied by, it is also 1 multiplied by 1 minus P, 1 minus 0.4 to 3 equals 0.6 cubed equals 0.216. Then calculate the next probability for the second value x2. P of x equals 1 out of the 3 equals C of 1 out of the 3 multiplied by P to 1 multiplied by 1 minus P to 3 minus 1 equals it is 3 multiplied by 0.4 multiplied by 0.6 squared equals 1.2 multiplied by 0.36 equals, and calculate this value 1.2 multiplied by 0.36 equals 72, and here 36 equals to 3, 4, 0.432. Now continue our calculations. Then calculate P if x takes 2 out of the 3. According to the binomial distribution, it is equal to c of 2 out of 3 p squared multiplied by 1 minus p to 3 minus 2 equals, it is 3 multiplied by 0.4 squared and multiplied by 0.6 equals 3 multiplied by 0.16 multiplied by 0.6 equals 0.48 multiplied by 0.6, and calculate this value. 0.48 multiplied by 0.6 equals 8 to 8 0.288. And finally, calculate the p of x equals 3 out of 3 equals c 3 out of 3 multiplied p squared multiplied by 1 minus p to 3 minus 3 equals, it is 1 0 point cubed, and it is also 1 equals 0.064. Then remember the value of mathematical expectation mx equals x1 multiplied by p1 plus x sub 2 multiplied by p sub 2 plus x3 p3 plus x4 multiplied by p4 equals, x1 is 0 multiplied, and its corresponding probability is 0.216 plus x sub 2 is 1 multiplied by, the corresponding probability is 0.432 plus continue plus x sub 3 is 2 multiplied by the corresponding probability 0.288, and finally plus 3 multiplied by 0.064. Then calculate 0 plus 0.432 plus 0.576 plus 0.192. Then summarize the obtained values. 0, 0, 0, 2, 0, then 1, and I'm sorry, calculate 0 point plus point 2 to 1. It is equals 1.4, and it means we have 1.2 hit onto object. Now rewrite your homework. One shot onto object is realized. The hit probability is equal to p. Define the mathematical expectation of the discrete random variable x of the hit's number. Now consider the several examples about the binomial distributive law. Consider the first example. Define the probability of that the event A is realized at least once. At least once. First, remember the main probability identity. Sum for y from 0 to n of p sub I is 1. Or p0 plus p1 plus p sub 2 plus etc. plus p sub n equals 1. According to the condition, the event A is realized at least once. It means the event A can be realized once, twice, or 3 times, or 4 times, etc., or n times. P of x is greater than or equal to 1. It means at least once. And it means also p of x equals 1 out of n. Is 1 out of n, or x equals 2 out of n, or etc., or x is n out of n. And according to the addition theorem, you know that the probability of sum is equal to the sum of corresponding probabilities. P of x equals 1 out of n plus p of x equals 2 out of n plus etc. plus p of x equals n out of n. Or we can rewrite the last expression in the following form: p1 plus p2 plus etc. plus pn. Then use the main probability identity. We can add and subtract the p sub 0. P sub 0 plus p sub 1 plus p sub 2 plus etc. plus p sub n minus p sub 0. But it is 1, and we have that 1 minus p sub 0. Now go to the second example. 4 independent tests are realized. The probability of event A appearance in each test is 0.5. Define the probability that the event A will be realized at least twice. Now show solution. According to the question, we must find the following probability: P of x is greater than or equal to 2 of 4, because we have totally 4 independent tests, and it means P of x equals 2 out of 4, or x equals 3 out of 4, or x equals 4 out of 4. According to the addition theorem, we can rewrite the last expression: P of x equals 2 out of 4 plus P capital of x equals 3 out of 4 plus P capital of x equals 4 out of 4. Remember the binomial distribution. C of 2 out of 4 multiplied by p squared multiplied by 1 minus p 2 4 minus 2 plus C of 3 out of 4 multiplied by p cubed multiplied by 1 minus p 2 4 minus 3. and finally plus C of 4 out of 4, P to 4 multiplied by 1 minus P to 4 minus 4 equals. Then calculate these terms. These terms equals, it is 6. 6 multiplied by P is 0.5. P is 0.5. 0.5 squared multiplied by 0.5 squared plus it is 4 P cubed 0.5 cubed multiplied by 0.5 and plus it is 1 multiplied by 0.5 to 4 equals, we have 11 multiplied by 0.5 to 4, 11 multiplied by 0.0625, and then multiply this expression, this number 0.0625 multiplied by 11. 5, 7, 8, 6, 0 point. We have 0.6875. It is answer. Now consider another method of this problem solving. We must find the following value: P of x is greater than or equal to 2. Equals P of x equals 2 out of 4 plus P of x equals 3 out of 4 plus P of x equals 4 out of 4. Then remember the main probability identity, and rewrite this expression as P sub 2 plus P3 plus P4. Here we can add and subtract P0 and P1. P0 and P1. P0 plus P1 plus P2 plus P3 plus P4 and minus P sub 0 minus P1 equals, it is unit minus P sub 0 minus P sub 1 equals 1 minus C of P of x equals 0 out of n minus P of x equals 1 out of out of 4, 1 out of 4. 4. It is 4. 4. Then remember the binomial distributive law. 1 minus C of 0 out of 4 multiplied by P to 0 multiplied by 1 minus P to 4 minus 0 and minus C of 1 out of 4 multiplied by P to 1 multiplied by 1 minus P to 4 minus 1 equals 1 minus, it is unit 1, multiplied, it is unit 1, and it is 1 minus 0 point is 0.24 minus, it is 4 multiplied by 0.5 plus, multiplied by 0.5 cubed equals continue in the upper part. Equals 1 minus 0.5 to 4 minus 0.5 to 4 equals 1 minus 5 multiplied by 0.5 to 4 equals 1 minus 5 multiplied by 0.0625 multiplied by 1 minus multiplied 0.0625 multiplied by 5 equals 5 2 1 3 1 equals 1 minus 0.3125 equals 0.6875. You see that we obtain the same result. Now rewrite please corresponding homework. 5 independent shots on 2 targets are realized. The probability of the hit in each shot is 0.2. Define the probability of hit on 2 targets under at least 3 shots. The next topic is the mathematical expectation of the binomial distribution. We must prove the corresponding formula mx equals n multiplied by p. We must prove this formula. Here n is the number of total number of all tests, and p little is the probability of the event A appearance in each trial, in each test. Proof. At first, form the distributive table. From 0, we must begin from 0, p sub 0. Etc. M, Pm, etc. and Pm. According to the formula of mathematical expectation for the binomial distribution, we have mx is x0 multiplied by p0 plus x1 p1 plus x2 p2 plus etc. plus xm pm plus etc. plus xn by pm n. x0 is 0, x1 is 1, x2, xm, etc. xn. Substitute these values. 0 multiplied by P0 plus 1 multiplied by P1 plus 2 multiplied by P2 plus etc. plus M multiplied by Pm plus etc. plus X sub n multiplied by P sub n. Then remember the formula of binomial distribution. 0 multiplied by C of 0 out of n, P to 0 multiplied by 1 minus P to n minus 0 plus 1 multiplied by C of 1 out of n multiplied by P to 1 multiplied by 1 minus P to n minus 1 plus 2 multiplied by C of 2 out of n P squared multiplied by 1 minus P to n minus 2 plus etc. plus C of m out of n multiplied by m multiply. Continue on the upper part of the board plus etc. plus m multiplied by C of m out of n multiplied by P to m multiplied 1 minus P to n minus m plus etc. Finally n multiplied by C of n out of n multiplied by P to n and multiply 1 minus P to n minus n equals. Continue. This term is 0 because the expression is multiplied by 0. It is 0. Then write 1 multiplied by n, 1 multiplied by n, multiplied by P, and multiplied by 1 minus P to n minus 1. N minus 1 plus 2 multiplied by, it is n minus 1 over 1 minus 2 multiplied by P squared multiplied by 1 minus P to n minus 2 plus etc. plus m multiplied by C of n of m out of n P of to m multiply 1 minus P to n minus m plus etc. plus finally it is 1 n multiplied by 1 multiplied by P to n multiplied by 1 minus P to n to 0. Then we can take n and P out of the bracket. Continue. N multiplied by P multiplied by, it is 1 minus P to n minus 1 plus here 2 and 2 are simplified and n minus 1 multiplied by P multiplied by 1 minus P to n minus 2 plus etc. plus we cannot write this term. Please write also only the last term plus P to n minus 1 multiplied by 1 equals. Then remember the Newton binomial formula. we can rewrite the last expression in the following form. N multiplied by P, it is 1 minus P to N minus 1. C of 0 to N multiplied by P to 0, I'm sorry, C of 0 out of the N minus 1, because it is also is unit. It is unit. Multiply P to 0, it is also unit, and multiply 1 minus P to N minus 1, plus. Then rewrite the second term in the following form. N minus 1 is C of 1 out of N minus 1. Multiply P to 1, and we rewrite 1 minus P to N minus 2 in the following form. 1 minus P to N minus 1 minus 1. It is N minus 2. Plus etc. and rewrite the last term, C of N minus 1 out of N minus 1, it is 1, multiplied by P to N minus 1, multiply, 1 is 1 minus P to 0, and we can write 1 minus P to N minus 1 minus N minus 1, N minus 1. N minus 1, because it is 0. N minus 1 minus N minus 1 is 0. 1 minus P to 0 is 1. It is 1. It is also 1. And it is P to N minus 1. N minus 1. And remember the Newton binomial. N minus P. Rewrite the expression in the bracket in the following form. C of 0 out of N minus 1 multiplied by 1 minus P to N minus 1 multiplied by P to 0, P to N minus 1 minus 0. It is first term. Then write second term plus C of 1 out of N minus 1 multiplied by 1 minus P to N minus 1 minus 1 multiplied by P to 1 plus etc. plus, and finally write the last term, C of N minus 1 out of N minus 1 is 1 minus P to N minus 1 minus N minus 1 and multiply P to N minus 1. Then continue, equals N multiplied by P, it is sigma M from 0 to N minus 1, C of M N minus out of N minus 1 multiplied by 1 minus P to N minus 1 minus M multiplied by P to M. If M equals 0, we obtain the first term. C of 0 out of N minus 1 multiplied by 1 minus P to N minus 1 minus 0. We have N minus 1 minus 0 plus. If M is 1, we obtain C of 1 out of N minus 1, N minus P to N minus 1 minus 1 multiplied by P to 1, plus etc. And finally, if M is the last value, N minus 1, C of N minus 1 out of N minus 1 equals multiplied by 1 minus P to N minus 1 minus N minus 1 and multiply p to n minus 1. But already it is the Newton binomial n multiplied by p, 1 minus p plus p 2 n minus 1. But it is minus p and p are deleted. Then we have n minus 1 multiplied by 1 to n minus 1, it is 1, and we obtain n multiplied by t. Remember the general formula of Newton binomial. According the Newton binomial, a plus b to n equals sigma for m from 0 to n is c of m out of n multiplied by a to n minus m multiplied by p to m. It is Newton binomial. But if n is n minus 1, we can write the corresponding formula, also the corresponding formula. A plus b to n minus 1 is sigma for m from 0 to n minus 1 of c of m out of n minus 1, a multiplied by a to n minus 1 minus m multiplied by b to m. Here a is 1 minus p, a is 1 minus p, and b is p. Now, if you have questions to me, you can write my email. mserifli at beu point edu point az. Thank you very much. Thanks for your attention.